Good morning students. Next our experiment is Norton's Theorem. So what is a statement of Norton's Theorem? This Norton's Theorem is completely inverse of Thevenin's Theorem. It's mean in Thevenin's Theorem current voltage source in series with the Thevenin's resistance and load resistance. But here in this Norton's Theorem current source in parallel with the Norton's resistance and as well as load resistance. Okay, so what is the major difference for that one and this one? In the sense, in Thevenin's theorem we are taking voltage source, here we are going to take a current source, and in Thevenin's theorem we are taking a series resistance, that one is a Thevenin's series resistance, and load resistance also series resistance. But here we are taking that resistance is in parallel with the current source, that resistance is Norton's resistance, and even though load resistance also in parallel with the current source. Okay, this is the major difference between a Thevenin's theorem and a Norton's theorem, you remember here. And here the statement, majorly the statement is Norton's theorem states that in a lumped linear network, the equivalent circuit across any branch is replaced with current source in parallel a resistance. Okay, so simple statement we need to take it, current source in parallel with Norton and load resistances. You observe here one circuit is there, so related to this statement only this circuit, you remember current source in parallel with Norton and as well as load resistance. Okay, so this is the actual statement. Here IN is a Norton's current, RN is a Norton's resistance, RL is a load resistance. Okay, you remember here we can compare Thevenin's theorem. Here also we are going to calculate three major values. One is a load current, another one is a Norton's current, another one is a Norton's resistance. We are going to calculate these three values, okay, here in this Norton's theorem. Then we are going to calculate first one. What is the first one? Load current. We need to calculate load current first. Okay, so load current IL equal to Norton's current IN into RN by RN plus RL. So we are calculating IN and RN, then it will be easy to calculate load current IL. So before going to calculate this load current, first we need to calculate IN and RN, Norton's current and Norton's resistance. Then only it will be possibility to calculate load current IL. Okay, so here already I said IN is a Norton's current and RN is a Norton's resistance, RL is a load resistance. So Norton's current first we are going to calculate. So Norton's current IN equal to total current in the circuit into opposite resistance by total resistance. It's mean according to our conditions, we have some conditions to calculate this Norton's current. Then I will be going to explain that conditions also. So you remember for based on that conditions where we done short circuit, so from that place we are we are going to take opposite resistance and total resistance. So next, Norton's resistance. Norton's resistance we are going to calculate Rn equal to R1 into R2 by R1 plus R2 plus R3. It's mean where we done a short circuit, so it's mean there is a conditions for Norton's resistance calculation also. I will tell you that conditions also. Next, okay. Here according to that condition where we done a short circuit, it's mean voltage source, here we are going to do a short circuit. From that place we are going to take a resistance calculation according to reduction technique. Okay, so you remember here R1 and R2 are parallel, so these parallel resistances are in series with the R3 resistance. Okay. Then you remember this is the actual circuit diagram. We will be going to solve this Norton's theorem. Okay, so here you remember I am going to take a 15 volts source voltage, and R1 is a 82 ohm resistance, and R2 is a 150 ohm resistance, and R3 is a 47 ohm, and load resistance we are going to take 100 ohms. Okay, so eventually our requirement is to calculate or to measure the load current here. Okay, then we are going to calculate theoretical calculation. First we are going to calculate IN current. Okay, Norton's current, theoretical calculations. Okay, to find the IN current by using some conditions, we have some conditions. So by using those conditions only we are going to redraw this circuit diagram, then only it will be possibility to calculate IN current. You remember first condition is load resistance in short circuit condition. Okay, and here I am going to take 15 volts power supply and calculate total equivalent resistance by using circuit reduction technique. So according to these three conditions, then I am going to redraw the circuit diagram. So this is the actual circuit diagram according to above conditions. So first condition is we need to short circuit the load resistance. So here we have a 100 volts load resistance. That 100 volt load resistance I have done short circuit. Okay, remaining all the resistances are the same, R1 and R2 and R3. And here power supply I have taken 15 volts. For this 15 volts I am going to calculate Norton's current. Here 15 volts V, and RT I am going to calculate here. RT in the sense total resistance in this particular circuit. So where we done a short circuit, so this is a short circuit condition. So opposite of this short circuit condition only I am going to take a resistance values. So you remember where we done a short circuit, from that place to this place we need to calculate total resistance. So these two resistances are series resistances. So these two resistances are parallel resistances. These parallel resistances are in series with this R1 resistance. That one only I have written here formula, R3 into R2 by R3 plus R2, because these two are parallel. So these two parallel resistances are in series with this resistance R1. Okay, so here R3 47 ohms, R2 150 ohms, R1 82 ohms according to our circuit. Okay, so here I am going to substitute all the resistance values in this formula. RT equal to, we can get it here 117.78 ohms. Okay, then IN, it's mean Norton's current equal to voltage, whatever the power supply voltage we are taking, that voltage. So I have taken here V is 15 volts, that 15 volts by total resistance already we have calculated 117.78, that 117.78 I have substituted here. Then we got here 0.1273 amperes. So this is the Norton's current calculations. Then we are going to calculate Norton's resistance. So here this is the Norton's resistance. Here also there is some conditions to calculate Norton's resistance. First one is load resistance in open circuit condition, and the second condition is all voltage sources are in short circuit condition and all current sources are in open circuit condition, and third one is calculate total resistance by using the circuit reduction technique method. Okay, so based on these three conditions, then I am going to draw the circuit diagram, redraw the circuit diagram. Here first condition is load resistance in open circuit condition, load resistance 100 ohms in open circuit condition. The second one is all voltage sources are in short circuit condition. It's mean we have taken a voltage source here, power supply, input power supply, that voltage source I have done short circuit, and all current sources are in open circuit. In this circuit diagram there is no any current sources, because of that remain circuit is constant, then where we done a short circuit, from that place to we are calculating total resistance. Okay, you remember here we done a short circuit, so that's why only we are going to take resistance. These two resistances are first consideration. So here 82 and 150 is a parallel resistances, that's why I have written R1 and R2 by R1 plus R2, and these two parallel resistances are in series with this R3 resistance, that's why R3 in series. Okay, so then I am going to substitute all the resistance values here. Rn equal to 82 into 150 by 82 plus 150 plus 47, then we can get it Rn Norton's resistance equal to 100.01 ohms. Okay, this is the Norton's resistance calculation. Then we will go for calculation of load current. Okay, so according to Norton's theorem statement, then I am going to redraw the circuit diagram. You remember, according to circuit according to statement, IN is in parallel with the load resistance and as well as Norton resistance. That diagram only I have drawn here. So IN, Rn and RL. So RL already given in circuit 100 ohms, and Norton's resistance we calculated previously. So that Norton resistance is 100.01. Norton current also we have calculated, that Norton's current is 0.1273 amperes. Then we will go for load current calculation. Load current IL equal to Norton's current into Norton resistance by Norton resistance plus load resistance. So we can substitute all the values in this particular formula, then we can get it load current is 0.0636 amperes. So here all the current values are very less current values. Because of that we will go to take ammeter is milliammeter only. So these are the practical diagrams. So these practical diagrams only we will go to verify the practical values. By using these practical diagrams only we will connect in the circuit in the kit, then we will get all the values, Norton's current and the Norton resistance and load current. So we need to take a Norton's current by using this circuit. So here power supply is 15 volts I am going to take, and we need to find out Rn resistance. Then I am going to connect the circuit like this. Then we need to measure load current. Then I am going to connect this circuit like this. Okay, these three circuit diagrams are practical circuit diagrams. By using these practical circuit diagrams only we will go to measure the IN and Rn and IL. Okay, you remember this is our kit, Norton's theorem verification. So in this particular kit you observe here R1 resistance is 82 ohms and R3 resistance is 47 ohms and R2 resistance is 150 ohms, and here we are going to take a load resistance is 100 ohms. You observe here 100 ohms. Okay, here we have so many resistances, but I have done theoretical calculation only for 100 ohm load resistance. Because of that I am going to take a load resistance is only 100 ohm resistance here. Okay, so you remember here I have taken one multimeter for a measurement of Norton's resistance and as well as what actually power supply I have taken here 15 volts or 20 volts or 10 volts I need to measure by using this multimeter. And here I have taken one ammeter, that ammeter is 50 milliammeter, that one also DC, because here we are giving DC power supply. So you remember here this circuit only convert AC power supply into DC power supply, because here in our laboratory we have a AC power supply. That AC power supply here internally one circuit is there, so rectifier circuit. That rectifier circuit will be converted into DC. That DC power supply we are connecting from this to this, I mean this to this in the sense from this point to circuit diagram. Okay, then we will go for practical verifications. So first we are going to take IN IN circuit connection. You remember, according to this circuit diagram, then we are going to connect in this kit, then we will get IN current. You remember here 82 ohm resistance, 47 ohm resistance and 150 ohm resistance will not change. So here we need to do a short circuit here at load resistance, and we are taking here 15 volts power supply. Here 15 volts power supply we are going to take it. So you remember, I am going to connect circuit. First terminal is for first terminal and second terminal is for second terminal power supply. So this is a ground terminal and this is a phase terminal, and then I am taking one ammeter, that one is 50 milliammeter. That 50 ammeter I am going to connect here at load resistance place, because load resistance we done here short circuit. That short circuit place only we are going to take one ammeter. So that ammeter is 0 to 20 milliamperes, but here I have taken 50 milliammeter. You don't worry about that. Okay, so first terminal is connected for first terminal and second terminal is connected for second terminal. Then I am going to turn on the power supply. You remember, here I am going to check what actually the input power supply I have taken here by using multimeter. Okay, you observe here 15 volts exactly I have taken at power supply place. Then what actually our Norton's current according to our theoretical calculation? Okay, you observe here Norton's current. This is Norton's current actually 0.1273 amperes, but here we got 100.8 into 10 to the power of 3, because this is a milliammeter. So into 10 to the power of minus 3, in the sense we can get it 0.1. Here also 0.1. Okay, 273 we got, but here we got 4 or a 7. Okay, so it's mean 0.15 or otherwise 0.16 we got it here. Okay, but here we got 0.1273 according to theoretical. So this one is verified, Norton's current verified practically. Then we will go for measuring of Norton's resistance. This is our Norton's resistance measuring circuit. Okay, so these are the conditions and this is the Norton circuit diagram. So according to this circuit diagram, voltage source we need to short circuit. I am going to do a voltage source short circuit. Okay, then we need to take what actually the Norton resistance. That Norton resistance we need to measure between these two terminals, A and B terminals. It's mean where we done a open circuit, that place only we need to connect one multimeter, then we can get the Norton resistance value. So this is a multimeter actually. So in this multimeter, then I am going to connect it ohms. It's mean resistive measurement. 200 ohm resistive measurement I have taken here. You remember, here also we need to connect ohm and voltage and common terminal. So according to this circuit diagram, then we are going to measure Norton resistance. So first we need to do a short circuit here. I mean voltage source in short circuit condition. I have done short circuit here, voltage source, and then open circuit load resistance. So I have done open circuit, but here I have taken two terminals because this pin of this multimeter will not possibility to insert in this panel. So that's why I have taken two short pins. So then I am going to take these values. You remember, Okay, exactly 100 ohms, 100.6 or 5 ohms or varying like that. And you remember here Norton resistance also 100.01 ohm. Okay, so here we got only 100.5 or 43 at little bit variation resistance only. That one is not a huge variation. Okay, then we will go to measure load current. For load current measuring, this one only. So actually previously we measured Norton resistance 100.3 ohms. Okay, practically we observe that. And here also Norton's current 0.15 we observe. Okay, then we need to measure load current. For this load current measurement we need to connect circuit like this. So according to circuit diagram, first we need to connect power supply, first terminal for first one, and for a second terminal for second one, next one you have to observe 47 ohm resistance second terminal will be connected for ammeter first terminal. So this is the ammeter actually. So that ammeter first terminal I am going to connect for 47 ohm resistance second terminal. Then next ammeter second terminal will be going to connect for load resistance first terminal. So this is the ammeter second terminal. That ammeter second terminal will be connected for load resistance first terminal. Okay, so we have taken load resistance 100 ohm now, so that first terminal I have connected here. And next load resistance second terminal will be connected for power supply. Load resistance second terminal will be connected for then circuit is completely closed. Then I am going to turn on the power supply. Okay, you remember here I have connected at input place one multimeter. So you observe in multimeter 15 volts. Okay, it's varying a little bit. Okay, you don't worry about that. 15 volts I have taken power supply. Then you observe in ammeter we got 52.3 into 10 to the power of minus 3. It's mean this is a milliammeter, no? So that's why we need to take 52.2 into 10 to the power of minus 3. So what actually according to calculation we got load current value you remember here 0.0636 amperes. So this is a load current measuring. Okay, but here we got 52 only, so little bit it's mean 0.052. Here we got 0.063 because of here little bit power supply varying, no, not exactly 15 volts. Because of that little bit changes here. Okay, so compared to practical and theoretical, little bit variations definitely it will arrive. Okay, so theoretically and practically proved. Then we need to note it here IL is 0.5 5 to 4 amperes. 0.052, not a 5, 0.052, 0.052 amperes. Here theoretically 0.0636 amperes. Okay, once again you need to check it, practical diagrams here. These are the practical diagrams. Okay, thank you.